Hi everyone, and welcome to another episode of C++ Crash Course. I'm Nick from Coffee Before Arch, and today we're going to talk about enums or enumeration. So within C++ itself, there's oftentimes circumstances where we want to do something based upon a value, and those things will be, say, constant over time. So we may want to do something based upon maybe an integer value, but that integer value has a very specific meaning. So maybe we're using it as a flag, for instance. Maybe if we're modeling something like a cache in a computer, we want a clean way to, say, represent a cache miss, a cache hit, a reservation fail, etc. And maybe we don't want to make an entire class just for this. We just need to tell them apart and be able to reference them as something meaningful. So not as, say, if some variable passed in is equal to 1. Maybe we want to check explicitly if it's equal to, say, cache miss. So this is exactly what we can do with enumerations or enums. So we'll go ahead and look at a simple example with enum.cpp. So an enumeration looks like this. So they're specifically for giving some more meaning to integers. So basically what we do is we take the set of all integers, and then we say, okay, let's define a new way to call an integer. So in this case, we'll basically create a new data type that will be a subset of integers called suit t. And so we'll look at a deck of cards. So for the deck of cards, we'll have 4 suits: clubs, diamonds, hearts, and spades. Now, when we create a new variable that's of type suit, it has to be one of these 4. It can't be anything else. So it has to be either a clubs, a diamonds, a hearts, or a spades. And we can set these equal to be a specific number, say 0, 1, 2, 3, or we can leave them blank. If we leave them blank, they can be some integer, or if we want them to be a specific integer, we can make these whatever we want. So this could be 23, this could be 14 or 15, etc. But we'll go ahead and go back to it being 0, 1, 2, 3 in our case. So why would we want this? So let's say we have a function that prints the suit of a specific card, and it takes a suit as an argument. So consider the case if we used integers instead of our enum for suit. So if we use an integer, integers like 5, 6, 7, 8, 9, they're not tied with cards at all, right? So if we just passed in a 1, sure, that indexes into diamonds in this this array of characters over here, or array of C strings over here, and will give us diamonds, but the index 1 itself doesn't have any meaning. So if instead we were able to index this by, say, diamonds, well, that makes a lot more sense, and it's a lot more intuitive if you're reading the code. So we'll do exactly that as an example. So we'll create 2 cards, so card 1 and card 2, and we'll go ahead and we'll assign it to be clubs, and we'll assign it to be spades. So instead of having to say, card 1 is equal to 0 or card 2 is equal to 3, we can just say clubs, or we can just say spades. So this kind of abstracts away the number so that we can just care about the specific the enum itself. So what the description is. So in this case, it's a club. We only care if it's clubs, right? We only care if it's spades. We don't really care about the number behind it. So in this example, though, we do care about the number somewhat because we're using it to index here. But say if we were just doing a comparison, where if we could change this to a cascading set of if, else if, else statements, where it would be, check if suit is equal to clubs, if it's equal to spades, if it's equal to something else, and then we could completely get rid of the need for up here saying clubs is equal to 0. We could just say clubs. We could just say diamonds. So again, it's important to remember that we don't have to assign a value here. It's optional, and the values here can be any integer. So all we'll do in this example is we'll go ahead and we'll print out, we'll call the function print suit, which we'll call with this our new type, which is this suit T type, which will be either clubs, diamonds, hearts, or spades. And then it will return a char array or a pointer to a series of characters that will either be clubs, diamonds, hearts, or spades. So we'll print that out. So it'll say card 1 is a, for the case of card 1, it'll be clubs with a value. And then if we actually print out the value of these enums, they'll of course be integers, right? So remember, enums are a subset of integers. So they'll just have, whatever values either we assign to them or whatever values just get assigned to them if we don't say clubs is equal to 0. And then we'll print out card 2 as well. So let's go ahead and compile this. So g++-o enum, take an input file of enum.cpp, no errors, and we'll run it. So here, card 1 is a clubs with a value 0, and card 2 is a spades with a value 3. So again, enums are just a convenient way and a convenient way to represent certain data types without having to make a whole class. And it's also a good way to clean up your code and make it a lot more readable. So instead of passing around just any value of integer, you can say, we're passing in a cache access type, or we're passing in the suit of a card, which is typically a lot better in terms of code readability. So that's going to do it for today. As always, if we go to the GitHub page where all of this stuff is stored at github.com/coffeebeforearch, that's where all the code from previous videos and then every other series that we have is going to be located. So if we go ahead and just go there real quick, here we go. So in this case, over here, here's all the repositories, C++ Crash Course. We've got all the previous videos and the corresponding files to those videos, as well as my contact information in case you have an idea for a video. And so today we looked at miscellaneous topics, and it's going to be enum. So feel free to download this, play around with it. Let me know if you have any questions. And as always, I'm Nick, and I hope you have a nice day.